Hello. Today we will learn or discuss about the precipitation. What is precipitation? How we can measure the precipitation, and what is rain gauge networking or rain gauge network. Though the definition already given to you, but not directly. I have already told you that for now we need to consider that precipitation is rainfall. Any form of water, I have told you, maybe, that is any form of water if we get, then that can be called as a precipitation. The definition is like that the term precipitation denotes all form of water that reaches the earth's surface from the atmosphere. So any form of water, if it is coming to the earth's surface from the atmosphere, it will be called the precipitation. Like rainfall can be there, snowfall, hail, dew, those all the forms. There are several type of forms are there. Though in dew as well we are getting the water, but obviously that is not rainfall. Snowfall and hail are different. So various form of water, if it is falling, reaching to the earth's surface from the atmosphere, that will be considered as the precipitation. But I've already told you that rainfall in India, rainfall is predominant as a precipitation, as because we don't have that much amount of snowfall in overall India, obviously I'm saying, and a small amount of hail and dew. So majorly we are having rainfall, right? So what are the forms there can be? Already I've told you in the last slide that was written. First of all, we can have the rain. What will be considered as rain? That is the precipitation in the form of water. Drop lead size will be 0.5 millimeter to 6 millimeter, right? Now on the basis of the intensity is what? Intensity is the amount of water per unit time, right? The amount of water, if we are considering in terms of suppose millimeter, as because we generally consider the depth, I already told you. Now depth per unit time, either per minute or per hour, right? So that is the intensity. So on the basis of the intensity, there may be light rainfall, but the intensity is 2.5 millimeter per hour, moderate rainfall where the intensity is 2.5 to 7.5 millimeter per hour, and heavy rainfall where the intensity is 7.5 millimeter per hour or more. Next we are having snow, but the snow is nothing but the crystallized ice in the form of flaky form we are having, and the density is almost about 0.1 gram per cc. Drizzle, when the size of the droplets are lesser than 0.5 millimeter, then it will be called drizzle. So if it is more than 0.5 millimeter, then it will be called as rain, and if it is lesser than 0.5 millimeter, it will be called as drizzle. And obviously the intensity should be greater than 1 millimeter per hour. Next we are having glaze, where the rain or drizzle may come into the contact of cold ground, and due to that ice coating can be created or will be situated outside the droplets of the water. That will be called as glaze, where the sleet is the frozen raindrops. And how it is being frozen? When it is passing through air, right? Passing through the air, sub-freezing temperature, right? So if it is passing through the air with the sub-freezing temperature, it will eventually will be frozen, and that raindrops we can consider as sleet. Where the hail is showery form of precipitation, where lumps of that frozen rain will come into the picture, right, having a size greater than 8 millimeter. Clear? So those are the type of precipitations. Now, how we can measure the precipitation? I have already told you in the last class that we generally measure the precipitation in terms of the depth, right? In terms of the depth. So precipitation is expressed in terms of depth to which rainwater would stand on an area. If you store the water in a particular area, so the depth by which it is standing, this will be the rainfall amount or precipitation amount. Now basically why we are doing that, I have already told you, as because the area will be known to you, the catchment area will be known to you. So if you multiply the depth with the catchment area, you will get the volume of the rainfall. Thus 1 centimeter of rainfall over a catchment area which is having 1 square kilometer area, total volume of water we can get multiplying this and this, that is 10 to the power 4 cubic meter, right? Now what is the instrument by which we can find out the amount of rainfall or the depth of the rainfall? The instrument is called Raingauge. The instrument is called the Raingauge. So this is nothing but it consists cylindrical vessel where it is kept open to collect rain. So a vessel like structure where the top portion is opened. Now whenever you are installing this rain gauge in a particular point which is called station, we need to look for some sort of settings so that we can get the accurate data. What will be those things? Those are the safety measures we can say. That is, the ground must be level and in the open. Ground must be level, so it should not be inclined. Should be leveled properly. It should not be undulating as well. The instrument must represent a horizontal catch. So whenever, suppose you are having inclined surface, you cannot simply put the vessel like this, right? As because that open surface is not perfectly horizontal, as because it is inclined. So you have to make, you have to install the vessel like this, so that the opening will be horizontal, perfectly horizontal. The rain gauge must be set as near the ground as possible. Why? As because we know that with respect to the height, wind speed will be higher. So to reduce that effect, we need to install the rain vessels as much as possible near to the ground surface. The catch should be as much as possible near to the ground, but it must be sufficiently high, so you have to give some sort of height. Why? So that any sort of flooding, so you can install like this one as well, you can install inside the ground surface, right, inside the ground surface. So what will happen? Obviously we have already told you that if the intensity is higher, so it will not be, the amount will not be infiltrated inside the ground surface. So some portion will act like runoff, so it may get inside the vessel, or maybe whenever the raindrops are falling, some splashes can get into the vessel. So you have to provide some sort of height. The instrument must be surrounded by an open fence area of at least 5.5 meter by 5.5 meter. So there should not be any sort of obstructions, right? So open fence should be there. Now what are the, this is one sort of typical image of rain gauge. What are the type of rain gauges are there? Two type of mainly we can divide in two types, that is recording type and non-recording type. It doesn't mean that non-recording type will not record anything. It means it will not record automatically. Your manual recording should be there. You have to measure the rainfall. Okay. So if you consider the non-recording type rainfall, we are having this one, that is called the Simon's gauge. This is one typical image or figure of Simon's gauge with the perfect dimensions. Okay. So those dimensions are fixed. Right. You can see by the figure that it's a simple form of instrument. It is nothing but a vessel catching the rainfall so that it can stand in a particular area, so that we can measure the height. So this funnel will collect the rainfall, and it will eventually, the rainfall or the water will go to the vessel, and we can transfer into some measuring tubes, so that we can find out what is the amount of water or the height of water precipitation. Right. So this is non-recording type, as because you have to measure that. You have to come into the field, you have to collect the water, you have to collect the water from the vessel, and you have to see what is the amount of water in the measuring glass. Right. So every day at 8:30 AM in Indian Standard Time, generally it is been recorded, and during the heavy rainfall, the reading should be taken 3 to 4 times in a day. This is the non-recording type rain gauges. In case of recording type, we are having 3 majorly recording type of rain gauges out there, that is called tipping bucket type, weighing bucket type, and natural siphon type. What is tipping bucket type? Tipping bucket type is this one. right? You can see one balance type of structure is there. Two buckets are there. This is one bucket, this is another bucket, and it is situated in a hinge, so it acts like a balance. Here one funnel is there. Now if this is the initial position of the bucket and suppose we are having a rainfall, so what will happen? Obviously this funnel will collect the rainfall and the water will drain to this bucket. And what will happen? Obviously by the collection of the water, the weight in this direction will be higher than this one, so it will fall down or tip down in this direction. Then this bucket will be in the place of the initial one. Again the water will be collected in this bucket. Again it will be heavier than this one, as because this water will be drained out. So again it will tip in this direction. So we will have various tippings. Now this instrument is so balanced that after collection of 0.25 millimeter of rainfall, directly you can get 0.25 millimeter of rainfall, it will tip. Now this tipping actuates a electrically driven pen to trace the record with respect to a clockwork driven chart. So with respect to the time, we can get what is the amount of water or rainfall was there. This is tipping bucket type. Secondly, we are having weighing bucket type. What happens over there? You can see first of all this figure. Right? This is the figure. Weighing bucket type. This is one funnel is there, and this is one bucket which is situated over some weighing instrument or weighing mechanism, balance mechanism, right? So in this what happens, let us see first of all the theory, then we will explain to in the image that in this rain gauge, the rain is collected by the funnel and it empties the water in the bucket, which is actually situated over weighing scale. Now what will happen if rainfall is there? The weight of the bucket will be higher. Whenever it is being higher, that weight can be recorded, and that weight actually indicates the weight of the bucket and the content of the bucket, and that can be recorded in a clockwork driven chart. So basically it is giving, with respect to the time, it is giving the cumulative amount of rainfall, as because you are not emptying the vessel or bucket. So at a certain time, what is the weight? At a certain time, what is the weight? And at a certain time, what is the weight? As because it is the initial water was not emptied, so obviously this will give you the cumulative values. You can see in the figure, you can see that this is a bucket which is situated in the balance mechanism, and there is a drum which is actually rotating with respect to the time, and here is indicator, and which is actually connected to this weighing mechanism. So by the increase in weight, it will go downwards, and this will indicate in this clockwork driven chart. Nextly, we are having the natural siphon type. Sometimes it is called float type rain gauge. Now float means which is floating actually. basically this one, right? Here one float will be there. Again you can see one funnel is there, and which will be collecting the water, and it will be emptying the water in this vessel which is having a float inside it. So with respect to the increase in water, the float will float with respect to the height of the water. Let us see the theory, then we will consider that one. This type of the gauge is also known as float type gauge. Here the rainfall collected via funnel shaped collector is led into the float chamber, causing a float to rise. Right now, the flow, because the float is rising, a pen is attached to the float, and it will record the data in the clockwork driven chart. Now, why it is called a natural siphon type gauge or siphon type gauge? Just because siphon mechanism is there for emptying the water. What will happen if the collector is full? Then what will happen? Here siphon mechanism is there. Actually this mechanism will empties the, or this mechanism will empty the water from the chamber, right? You can see this one, right? You can see this one. Now I've already told you this rainwater will be collected, and this will empty the water in this chamber. This chamber is consist of float. So with respect the rise in water level, this float will be rising, and with respect to the float, the pen is connected in this clockwork driven chart, which will be rotating with respect to some time, and it will be indicating what is the amount of precipitation with respect to time. And when it gets this site, as because whenever you are having this site, this is also filling this chamber, and if the height is this one, a siphon mechanism will be there which will empty the chamber, right? So those are the type of rain gauges. Now we will see the rain gauge network. What is rain gauge network? Let us see, or let us say, suppose we are having a catchment area which is suppose you are having one catchment which is having area. Obviously this area will be large, and somewhere here you are having one station, rain gauge station. On the basis of the recording by this rain gauge, can you say that this was the amount of rainfall over the catchment area? Can you say that? No, we cannot, right? As because it's just a tiny portion it is covering with respect to the catchment area. So to know the actual situation, or somehow actual, obviously you will not get, but the accuracy you will get. To increase the accuracy, what you can do, you can install more number of rain gauge stations in various places. If the number of rain gauges are higher, then obviously the accuracy will be higher. So this thing is called the network or rain gauge network. So the catchment area of a rain gauge is very small compared to the areal extent of the storm. Hence, to get representative picture of a storm over a catchment, the number of rain gauges should be large as possible, as large as possible. However, obviously, the cost associated to that installation, maintenance, various sort of problems are there, so we cannot, obviously there will be some limitations. So that is called the rain gauge network. Now, what will be the optimum number of rain gauges there should be? The World Meteorological Organization, or WMO, it is referring that the number of rain gauge station with respect to the various areas should be this one. For flat region, if the condition is if this is the ideal condition should be, if you are installing one station, at least one station for 600 to 900 kilometers square. So if your catchment area is suppose around 16 kilometers square, then you have to install 2 stations ideally. But one station for 900 to 3000 square kilometers is also acceptable, just acceptable. Likewise, for mountainous region, we are having one station per 100 to 250 square kilometer. Acceptable can be one station in 250 to 1000 square kilometer, and in arid, and polar zones, the station numbers would be this one, right? Next, we are having the guidelines given by the Indian standard IS 4987 1968. According to this IS code, there should be one station per 250 square kilometer in plain region, one station per 260 to 390 square kilometer in regions having average elevation of 1000 meter, and one station per 130 square kilometer if it is predominantly hilly, right? So out of which 10% of the rain gauge stations should be equipped with self-recording. 10% recording time rain gauge should be there. Those are the guidelines given by the Indian standard. Now let us look at the adequacy of rain gauge stations. What will be the optimal number of rain gauge station in a particular area with respect to the allowable degree of error? Obviously, I have already told you, if the number of rain gauge stations is higher, the error will be less. So what is the allowable error you are considering? If the allowable error is lesser, the number of stations should be higher, right? So Suppose if in a particular area is there already some rain gauge stations are there, right? The optimal number of rain gauges, which we can denote it as n, will be equals to this optimal number of rain gauge station in that station, where epsilon is nothing but the allowable error, degree of error, and CV is the coefficient of variance, coefficient of variation in the rainfall values. Now how to find out this? This we will decide, right? This we will decide what should be the allowable degree of freedom, and CV, what will be the value of CV. CV can be calculated in this way, that if there are already m number of stations already there, I have already told you that there are some rain gauge stations are already there, and 1 2 3 4 5, here 5, so basically m is nothing but 5. What will be the number of optimal number of rain gauges if our allowable degree of error is this one, epsilon? So with respect to the existing rain gauge stations, we will have some data. If 5 number of stations are there, 5 number of data we will have. So rainfall, if m number of stations are there, suppose we are having m number of stations, so we will get for each and every station precipitation P1, P2, P3 up to Pm. These are nothing but the depth of rainfall, either per day, in a particular day, in a particular month, in a particular year or something. So those are the precipitation data of m number of stations. So CV, in that case, CV will be equals to 100 multiplied by sigma m minus 1 divided by p bar. Now here again, p bar is nothing but the average rainfall. How to find out average rainfall? Simply arithmetic mean. That is, sum up all the precipitation existing values, P1 plus P2 plus up to Pm, and that will be divided by m. Right, so summation of Pi, where I will vary 1 to m, divided by m. And what will be the value of sigma m minus 1? Sigma m minus 1, that is the standard deviation, that will be equals to root over summation of Pi minus P bar. So basically this is nothing but P1 minus P bar whole square plus P2 minus P bar whole square up to Pm minus P bar whole square. Right, so Pi minus P bar whole square, where I will vary from 1 to m, this one, divided by m minus 1. This will be your standard deviation. So all the values are known right now, right? To find out CV, you need to know P bar. P bar is known as, because P1, P2, P3 up to Pm is known. Standard deviation you can find out by this equation, where Pi is known, P bar is known. So you can find out the CV. Let us take an example like this one. Here 6 stations are given. So they have said in a catchment area already existing stations, 6 number of stations are there. AF will be there, huh? AF will be also there. So in a particular year, annual precipitation was recorded in centimeter is this one. For in catchment in rain gauge station A, this is recorded, station B it is recorded, station C it is recorded, and so on. So they have said, first of all, that determine the standard error for the existing Raingauge station. So if you are having 6 number of Raingauge station in a particular catchment area, 1 2 3 4 5 6 number of stations are there. So what is the error right now? And secondly, they have said, if you consider 10% of error, if you allow 10% of error, then what should be the optimum number of stations in the catchment area? So first of all, what we have to do? First of all, we need to find out the error. What is the current error? Right? Now, to find out the current error, this formula we need to use, but instead of n, as because we are not considering the optimal number of Raingauge station, we are having number of Raingauge station as m, and we are finding out the epsilon. So n will be equals to m, and with respect to m, we will find out what is the epsilon. So first of all, we need to find out CV, and to find out CV, we need to find out sigma m minus 1, and to find out sigma m minus 1, we need to find p bar. So Raingauge station number is m. After calculation, p bar is this one, and p bar is nothing but summation of pi, where here I will vary from 1 to 6 divided by 6. P1, P2, P3, P4 and P5, P6, summation of those 6 divided by 6. The calculation, after calculation, this is the p bar. Formula of sigma m minus 1 is given to you. From the formula you can find out sigma m minus 1 standard deviation, that is root over summation of pi minus p bar whole square divided by m minus 1. Here again m is 6. You can find out the standard deviation. After finding out the standard deviation, you can find out the CV, coefficient of variation. That is by this formula. You have got the value of this, value of this. You can find out what is the coefficient of variation. So first of all, we need to find out what is the error associated to the current number of Raingauge stations. So the formula will be same. What was the formula? The formula was this one. So basically n, as because here n is equals to m, this is CV divided by epsilon square. Now this is known, this is you need to find out. So epsilon will be equals to CV divided by root m. This is, you have already got, 6 is known. This is the associated error right now, 12.606%. Now they have asked another thing, that is, if you need to allow 10% error, then what will be the optimum number of Raingauge station? Now the formula will be same, n is equals to CV divided by epsilon whole square. Here n is unknown, sigma is, epsilon is known, that is 10. CV will be same. You can find out what is the number of optimum number of stations. Now number of stations cannot be, should be integer value, right? It will not be in decimal. So this will be almost equal to 9. 9 Raingauge stations is the optimum Raingauge. So already 6 was there. So what would be the additional Raingauge station? 9 minus 6, that is 3 number of Raingauge station you need to install. Right. This is about the measurement of Raingauge network and the optimal number of Raingauge stations in a particular area. Okay.